VTX occasionally gives a little flick of RF power. Alright, put this on here. And okay, it's dropped right off. It means that there's a good match now. This is fully terminated. The power is it'll actually go back the other way. There's no power reflected, it's all absorbed because the through line's been adjusted, and that means that there's no RF into the Schottky diode. Right, but if I take now, I said there's a bit of plastic both ends of the through line. If I take this one here out, which you're not going to be able to see, I don't think. Anyway, I'm going to move this one. Watch the needle. Right, you see it's jumped up. If I took the one out of the other end, it would go up even higher. So there's a bit of plastic which looks like it's a taper. So as you push it in, it gets wider, and you put it in, and you fiddle around a little bit. And you see there's a dip. If I can get it in exactly the right place, should get it back to where it was before. Oh, there you go. Right, so once it's in exactly the right place, it's then matched the line to the load. Through line's then matched to the load, as seen by the VTX. There's no reflected power. Now because there's no reflected power, there's really no voltage out of here. This is why this is down here near zero. So it's pretty pointless trying to calibrate the second or the coupled line without any power. So we'll make some power for it. Also, every time you do these adjustments, by the way, the forward power needs to be checked because it also interacts. Okay, we put 6 dB attenuator on it. Okay, 1.7. There, oh, that's my just poked my stick into my my monitor. Okay, 1.7. Oh, I just touched the battery. It changed. 1.7, which is correct. Okay, so now we're going to have to adjust that because there's forward power, and you want to get this coupled line right. You put this blade very carefully under the coupled line, and you can just gently lift it up. See that? And you can actually move the. Just don't do it too much, and you can move it up and down until it reads what you want. So now there's it's reading 1.7, which is correct. You take it off. See if the by the way, that will change because you've changed the impedance of the coupled line. It can change the reference voltage. It didn't though because it's all tuned. Right, so that's the first set of steps. The second thing you do now, you've got to depower it, turn it around, and repeat the test exactly for the other coupled line. In which case, because it'll be turned around, you then have to adjust this will be the output, that'll be the input. This one here, this plastic strip here will need to be adjusted. And 2 or 3 times, by the way, and in the end you'll get the through line showing almost reflected power. What else was there? Well, that's more or less it, guys. So just in summary, there's just 2 plastic tapered strips that go under the through line. They're not under the coupled line, and you just keep using the output side to get a match with 0 reflected power. Turn it around, then the output becomes the input. Do the second side, back and forwards a couple of times, and you definitely need attenuators. So that's terminated, no power reflected, and oh, I suppose I could show you. Here we go. Okay, so that's terminated, no power reflected. Now you'll find that moving this doesn't make much difference. There you go. You probably can't see it move, but it's moving it. It's because there's no reflected power. It doesn't matter what the coupling is. There's nothing to measure, so there's going to be no indication on the meter. You need some VR. Okay, set's alright. Back onto VR. It's reading 1.7.